Hi everyone, my name is Kalyan. Today I'm going to give a short overview on my final year project Time Synchronization and Networks, which is guided by Dr. Chandramani Singh. So in this presentation, I'll go through introduction at first. Thereafter, I'll go to present time protocol. Thereafter, I will discuss about P4 language programming. Thereafter, I'll go to linear regression algorithm. And finally, I will go to some workarounds and resolutions which I have done in my project. And finally, I will conclude the presentation. So coming to introduction, time synchronization means in a network we will have a different nodes and all nodes have their own clock. So time synchronization means we need to align all the clocks in the same fashion. So same fashion in the means if there is any difference in the offset, initial offset, we need to align at the same point, and even if the speeds are different by means of frequency, we need to align. So that's what time synchronization means. And this time synchronization is having many application in time sensitive networking in ethernet. So this TSN is widely used in industrial automation, aerospace, transportation, and many other applications. So for this time synchronization in our project we used a protocol called PTP. PTP means precision time protocol. So with this PTP we can achieve precision up to nanoseconds. So in PTP what it will do is it will assume among the nodes in a network one node as a master clock and remaining all clocks as a slave clock. So the duty of this master clock is to send some messages to the slave clock, and by means of some time stamping mechanism the slave clock will try to adjust to the master clock. That's what whole PTP does. So earlier we used to have NTP, but PTP offers much more higher precision than NTP. So these are the different clock types in a PTP. First one is Grand Master Clock. Grand Master Clock means among the nodes in a network, like we will have different clocks, right? So among the all clocks, the most precise clock we will take it as a Grand Master Clock. And boundary clock means it will act one side as a slave and another side as a master. So it is very much important because it will try to reduce the load for a grandmaster, because if there is no boundary clock the master has to send messages to all the slaves, so it will which eventually increase the load for master. So if we have a boundary clock, it will try to synchronize boundary clock, and boundary clock will take up the duty of synchronizing remaining slaves. Coming to transparent clock, it's neither as a act as a master nor a slave. It will just forward the packet, but while forwarding it will add its own delay and give some kind of information. That's it. And it will allow only when we have same VLAN ID. So these are the different types of messages that we have in a PTP. One is sync message, follow-up message, delay request message, delay response message. So that I'm going to discuss. And from this mechanism, we will try to find two parameters. One is offset and another one is delay. So here you can see there is a master and slave, and master is sending two messages, sync and follow-up, and to this the slave will reply delay request. To this the master will reply delay response. So when through this mechanism we have four timestamps t1, t2, t3, t4. So and we have formulas delay and offset. So we can see at the initial we will have an initial offset 9. If it is started at 9, it is at 9:10. So that we can find out by using this formula. And we have some delay, transmission delay, that is 1 second, that we can find using this. So this is the basic template, like basic header um, message format of a PTP message. Header will have 34 bytes and body can be any length. So in this header we will have some message type. From this we can try to find what kind of message it is, whether it is a sync or follow up or delay request or delay response. Everything we can find using this message type. And body, we will all the timestamping information that it captured will be added to this body. So P4 means, so in our project we have tried to implement this clock in P4. P4 means nothing but a, a, a language for implementing our custom protocols. So we have tried to implement this PTP using P4 language. So what it will do is, like this P4 is mainly meant for implementing these protocols at the data plane. So if we data plane in the sense like it will do every calculation at the hardware level. So earlier we in NDP we used to do calculations in a control plane. Control plane means the CPU will calculate all these delays and offset, which will used to add some overhead. That's why we used to get not precise values, not having a precise synchronization before. But due to this data plane thing, we have a much more accuracy. So that's why we have used P4 in our project. So P4 works with a pipeline structure. So it will have a parsing stage, and after that match action stage. In parsing stage, what it will do is it will, whenever any packet comes, it will try to identify what kind of packet it is, and based on that it will try to do action using match action table. Control plane means it's like it will add rules to the P4 thing, and it will try to uh, it will add some kind of dynamic rules to the data plane. And egress pipeline is like all the information that it will all the information, all the actions which will do, it will result in some kind of info that will be again added to the packet in the egress pipeline, and after that it will go out of the data plane. So this is the basic overview. So whenever any packet comes, it will go to input and go to pass stage, and after it will go to match action table, and after that in egress pipeline also it will go to some match action table, then depass and output. So this is the uh, basic hardware setup that we have used. So we try to load our program in the metronome, and we have connected to the Intel NIC, and Intel NIC is the place where we have connected two hosts H1 and S2, and we are trying to implement a boundary clock. So using this we will try to implement a algorithm called linear servo algorithm. In that setup we have tried to implement this linear servo algorithm because uh, usually this servo algorithm is implemented in the control plane, but that result, as I said before, that result in uh, very high overhead. So we have implemented this algorithm in data plane, it result in very high accurate values. So this is the flow chart. So what it will do is it will try to take the past offsets and past timestamps, and we'll try to do some linear regression operation, and we'll try to calculate slope and intercept. So from that, when we give any current timestamp, it will try to predict the offset, and it will do clock adjustment based on this predicted offset, and it will synchronize the clock. That is the overview of linear regression. So this is the project, like this is the formula that we have used. This is for just kind of reference. So in this is the formula, like all the past offsets from all the past offsets and past timestamps we can use, we will try to compute, and we will try to find these two parameters m and c, slope and intercept. So whenever any new timestamp x comes, we can try to find the predicted offset y cap using this formula. So this is the graph that I got with actual offsets, like which is blue color from the, and at the starting you can see the predicted offset. It is at the starting it is somewhat not not aligned with the blue line, but after some time it will align with the blue line. So that's what you can see. So here you can't see much difference, but in a table you can see, like we can see we have so many values, and there are some matchings also there. So over the time it will match. So that's what this whole program is about. And since it is a data plane, it is much more accurate. You can see only last 4 digits are changing, remaining is almost equal. So that's what our project is mainly based on. So coming to workaround, like we have tried to implement this linear regression in a micro C in P4. So yeah, there is some kind of Indian problem between P4 and micro C that we have solved using some volatile pointers, and we have some bitwise restrictions that we try to handle using 128 bit, which we try to resolve it using a structure. and there are no loops and recursions in P4. So we had tried to use the micro C extern engines to resolve that one. So coming to the conclusions, what I can say is this linear regression we have tried to implement on P4 in a Smartnik metronome uh, by using a micro C. So novelty is we have implemented all these things in a data plane. So it will try to reduce the offloading time. So that's where so it will be like it is a very important step in reducing the accuracy, reducing the overhead, and it will increase the accuracy. So that's what our project is about. Thank you.